Assalamualaikum warahmatullahi wabarakatuh and a very good morning. My name is Adam Haziq bin Zuraimi, ID 1900045, and I will be presenting about gravity anomalies, subsidence history, and the tectonic evolution of the Malay and Penyu basins. So as you can see, this is the table of content of my presentation. Now, I will present the introduction of Malay and Penyu basin. Okay, first of all, the northern Sunda Shelf between Peninsular Malaysia, Indochina and Borneo is underlain by three major tertiary continental extensional basins, which is the Malay Basin, the Penyu Basin, and West Natuna Basin. For your information, Malay Basin is the largest and the deepest basin, while Penyu Basin is the smallest. So, the exploration for oil and gas in Malay and Penyu Basin has been progressed almost for 3 decades, which means it already been progressed since a long time ago. While the negative free air gravity anomaly in the Malay Basin is negative 25 milligal, while for the Penyu Basin is negative 15 milligal. So, the gravity anomalies and tectonic subsidence in Malay and Penyu basins were analysed using well-established concept of lithospheric extension and isostasy. Now, I will present the background of study of Malay and Penyu basin. As you know, the Malay Basin and Penyu Basin are located at the center of the Southeast Asia. The core of the Southeast Asia, or Sunderland, is the eastern end of the Semirite Oregon that formed when the Paleotethys Ocean closed during the late Triassic times. So now, the present plate tectonic setting is dominated by active subduction zones and volcanic arc trench system that work as a mark. So as you can see, the location of Malay Basin and Penyu Basin is really near, since it is both located at the center of the Southeast Asia. Now, I will present the structure and the stratigraphy of Malay and Penyu Basin. The Malay Basin is an elongate basin about 350 km long and 250 km wide. The Malay Basin has a high heat flow, which means it is a reef basin. The extensional structure that associates with the basin formation is half grabens, which are bounded by major normal fault and filled by non-marine synreef sediments. The synreef structures can be observed only on the basin flanks, and the Malay Basin has evolved through four main phases, which is Oligocene extension and subsidence, early middle Miocene subsidence, middle late Miocene basin inversion, and late Miocene to recent subsidence. As you can see here, this figure shows the geological section across the Malay Basin based on regional and is subdivided into seismic stratigraphic units designed alphabetically from A to M downwards. So, for our problem statement and objective. So, the problem statement of this paper is the basin forming mechanism in Malay and Penyu Basin and their gravity anomalies, while for their objective is to gain a better understanding of the basin forming mechanism and to determine the possible cause of the gravity anomalies in Malay and Penyu Basin. Now, I will present about the methodology. As you can see, the methodology that we use is the modeling gravity anomalies. So, as you can see in the slide, those are the formula and the step that we have to take in order to find the gravity anomalies. Now, I will present the result and discussion of this paper. As you can see in figure 2, this is the principle of technique used in calculating the gravity anomaly of a hypothetical reef basin. So, this is the result of the gravity modeling line E. So, as you can see at the first picture, those are the gravity modeling that we get from line E. Line E is the line that have been stated in the slide, page 9. You can refer back if you want to know. So, this is the conceptual model for Moho elevation relative to the composition depth for a partially compensated basin. Composition depth is defined as the base, the unstretched crust. In the ideal area case, the crust is fully compensated by an elevated moho, the backstrip moho. For partial isostatic composition, the moho depth is deeper than the backstrip moho and is given by Yp. The degree of compensation is defined here as a fraction of backstrip moho elevation above the compensation depth, which is expressed in terms of depth measured relative to the surface. So, this is the result of gravity modeling tree profiles in the Malay Basin using a model of partial composition shown in figure 4. Top panel represents calculated and observed gravity anomalies. Bottom panel represents the crustal structure predicted using the backstrip tectonic subsidence in each case. Two types of moho are shown: the partially isostatic flex moho, calculated to honor the best fit gravity model, and the isostatic moho, which represent the completely isostatic flex moho. The expected moho depth if full composition occurs. Okay, for the A, line E, best fit calculated anomaly representing C equals to 0.77 while T equals to 0 km. Shown below is the crustal deduced from the best fit model of C equals to 0.77. So for our final result is these are the parameters that are derived from the result of the gravity modeling, which is from before. So stretching factor is based on maximum value at the center of the profile. Uncompensated subsidence represent the total tectonic subsidence minus the subsidence predicted by the partially compensated moho. So as you can see, these are all the results that we get from the gravity modeling method. So finally, I will present recommendation and conclusion. So for the recommendation, I would recommend to increase the scale of the gravity survey so we can get a lot more data. And as for the conclusion, the negative free air anomalies over the Malay and Penyu Basin were successfully modeling using structural backstripping and gravity modeling technique. The second one is Malay and Penyu Basin are underlain by relative thin crust but are not in a complete isostatic equilibrium. And the final conclusion is Malay and Penyu Basin were formed by a combination of thick skin and thin skin extension. So that's all from me. I hope that you enjoy the presentation. Thank you.